This is the machine that you will be using for circuit analysis. It allows us to build and test circuits. For our very first portion of the video, we will be going over the basic operation and the basic components that are used in the system. Before you start, make sure to take off all rings, necklaces, bracelets, and watches. The first step is to turn on the power for the desk using the switch at the top. The light on the switch will indicate that the power is on. Next, power on the machine to verify that it works, then shut it off before connecting or disconnecting the leads. You can change the voltage by using the small dial on the left labeled voltage adjust. At no point will you need to go beyond 12 volts. The switch next to that will change the reading on the display from volts to amps. Connect positive leads to the red port and connect negative leads to the black port. Typically, positive wires will be red and negative wires will be black, yellow, or green. Each machine comes with two trays of components. The bottom tray will contain a variety of resistors. The top tray will have components including motors, lamps, relays, diodes, coils, transistors, transformers, inductors, potentiometers, and switches. The breadboard, which attaches to the hatch of the machine, is where we connect all the components to create circuits. It is removable from the hatch if you want to close the machine without disassembling your circuit. To create a circuit, attach the components to the breadboard by using the pins on the component and the holes on the breadboard. You can connect the components directly in series with each other so power will run through them straight to a ground, or you can separate the components and attach them using a wire. The contacts need to meet with the copper conductors on the board to pass the current through the circuit. Components like switches can be used to block and/or activate other parts of the circuit. Our first circuit that we will be taking a look at is a series circuit. The example in the video consists of three components: a single pole double throw switch and two incandescent lamps wired in series. The current starts at the red lead and passes through the switch to the first light bulb, then to the second light bulb, then to ground. One effect of wiring components in series is voltage drop. The voltage is split between the two lamps, lowering their individual brightnesses. Our next example is a parallel circuit. There is no voltage drop in a parallel circuit because voltage is constant. The current passes through the switch, where it then redirects into two paths, which each power a lamp before connecting to ground, completing the circuit. Our next example is a combination circuit. As you can see, the circuit has two branches like a parallel circuit, but in one of the branches you find two lamps in series with one another. Notice that the branch in series has dimmer lamps. However, the second branch is brighter because it is a sole lamp. This is the result of voltage drop. Take a look as we take the lone lamp out of the circuit. The two in series stay lit, same as parallel, but if you take one of the series lamps out, the other in series will go out, but the lamp in parallel is still lit. The next circuit demonstrates the function of a relay. The relay changes the contacts of a switch through induction. The three main parts of the relay are the normally open contact, the normally closed contact, the common path, and the induction coil. When the coil has power, the normally closed contact opens and the normally open contact closes. For current to flow through the switch, there must be current through the common. Connect a reverse bias diode to the coil to prevent induction kickback. By connecting the normally open contact back to the coil, you can effectively create a latching relay. To unlatch the relay, open the circuit leading to the common. A good way to do this is by using a normally closed push button. Here are some examples of circuits that can be built using the components provided.